Hello and welcome back to the channel. Hey, I'm Ron with Ideal Industries, and in this segment we're going to talk about ideal testers and meters. And actually I want to talk about how do you choose a tester for yourself, because you know folks, when you go out and buy test equipment today, there are literally hundreds of choices, and there are dozens, if not dozens of manufacturers out there making test equipment. And you got to think about what you're looking at and make sure you get something that's safe, and then on B, make sure it does what you want it to do too. And you know, if you need one of those $2 or $3 things that light up when they hit AC or something like that, well then go buy that. You know, don't go buy some piece of test equipment that has a bunch of functions in it that you would never use and spend a bunch of money on. So you got to sit that back and ask yourself what you need the meter to do before you go out and maybe go buy one. And you know, I'll give you a hint. Once you take it home, you might read the instructions. You'd be surprised what you might learn. And I tell you, a lot of folks do stupid things with testers, and then they, you know, blow a fuse in it, or they can actually damage the equipment, or even worse. So think about what you're trying to measure and test, and then go out and find a product that does that. And I'm going to step you through some tips on what to look for when you're buying that piece of test equipment. Well, tip number one I can give you when you go out and buy a piece of test equipment is you might look to see, how do you know if it's safe to use, I guess is a good question, right? So how do you know? And what I'm going to do is I'm going to look at the piece of test equipment, and I don't care who makes it. There should be a label on the tester someplace. And the label will tell you, in this case it's on the back, and it tells me a little bit, you know, who made the tester, and a little bit about that company. But it also, what I'm looking for are these third-party laboratory certifications or designations like UL or CSA or some other third-party lab. And what that means is this manufacturer has gone to the trouble of submitting their product to a third-party testing laboratory that would actually test the product, make sure it does what they say it's going to do, and it's safe to use in the environments that we say it is. So look for that third-party designation that tells you someone has taken a look at the tester, and if it doesn't have that, be careful, okay? Now, another little safety rating, which I'll talk about here in a minute, is this what we call category rating. But I'll warn you, any accessories you buy with the tester, make sure they go with the tester. Sometimes you'll find testers sitting there with you know, a bunch of them on a shelf someplace and a bunch of accessories nearby. And sometimes they are meant to be used with it, and sometimes they're not. So again, make sure it is what you need it to be. And when I look at the category ratings on the tester, and you're going to find this is a pretty important one too, right where the test leads go into the tester itself, usually there'll be what's called a category rating. Now UL a number of years ago comes up with these category ratings 1 through Cat 4, and Cat 1 being the lowest and Cat 4 being the highest, as a means of identifying where it is safe to use the piece of test equipment you got. And Category 1 testers is the lowest portion of this, and they're basically low voltage type testers, and they're not safe to use trying to measure AC in an outlet in a room or anything like that. So they're somewhat limited in their purpose, but certainly have their place. Category 2 testers, and for instance this little digital multimeter over here is a Category 2. Category 2 testers will allow us to measure safely at outlets in rooms and appliances and TVs, and of course anywhere we would use a Category 1 type tester. And for a lot of us, Category 2 might be just fine, okay? Now, Category 3 testers, and this one here in front of me says Cat 3 right there, is a product that is safe to use in electrical circuit breaker panels, you know, feeder circuits, out to branch circuits, out to outlets in rooms, and again into appliances, and again anywhere a Category 2 or a Category 1 tester might be used. So a lot of your professionals might be looking for a Cat 3 tester at a minimum. And then Cat 4, which is the highest setting over here, this gets us outside the building into the utility side of the electrical services, and that's where they're safe to use. So be looking for the category rating on the tester. It's going to tell you a lot about whether or not a third-party lab has looked at this tester and where it is safe to use the product itself. So be looking for that category rating. Now, I'm assuming in this next tip that the tester you buy, you need it to measure AC voltages or currents, or maybe both. And for many of us, we do need that. Obviously, we're measuring voltages around the home, or obviously commercial work as well. So now, when you measure AC, it's not as easy as it is with DC circuits. You know, DC gives us a steady state of current or voltage. Pretty easy to measure, and you can be very accurate with your readings. Now, AC, or alternating current as the name implies, is always changing. Okay, and it's actually kind of hard to figure out, okay, what it is, you know. as far as being able to measure it. So now in AC, the guys will use what's referred to as use an oscilloscope to actually measure or look at this waveform, and it would be able to let us look at the voltage or current and what it's doing over time. Now oscilloscopes would end up drawing you something that looks like that little waveform you see over here, and that's called a sinusoidal waveform. Okay, now when we look at the waveform, it has a vertical line in it, okay, and it has a horizontal line, okay. Now, the vertical line would be the current or the voltage. Let's say it's voltage that we want to measure. This line here is what's happening over time, okay? And when you look at this waveform here, you'll see that the waveform is partly above the line and it's partly below the center line. Now, the center line is set at 0 voltage, okay? And you can see that the waveform builds over time. It hits a peak, and then it comes back down, hits a center line, and goes to 0 volts again, and then it does the exact same thing in the opposite direction, okay? So half the time it's above, half the time it's below. And these two sides of the lines are considered the positive and negative component of that waveform, okay? Now, when we go to measure this waveform, you'll notice that it's referred to as 60 hertz, okay? Well, what's going on here is that it will create 60 of these little waves in 1 second, okay? So this goes on and on and on, right? In 1 second, it creates 60 of them. So this little waveform here, this point in time, represents 1/60th of a second duration, okay? So it's a pretty short period of time, but we got to try and measure this. Now, there are a few ways of measuring this, okay? One of the most common ways of doing it is what we call average responding testers, and for instance, this one over here is a basic average responding meter. Now, average responding meters have a device in them that can basically look at this waveform and actually quickly come up with the average value under the waveform, okay? And if this peak here happened to be a 1 volt peak, and we would then take the average value over time out of that peak, you would end up finding out that that average value ended up being at 0.637 volts average, okay? All right. Now, unfortunately, the average value is not the value we need to know. We need to know what's called the effective value of the waveform, or what portion of the waveform can be used and then turn around and actually do work with. So it's called the effective value. And if your tester has some words on it that says RMS or true RMS, that is a product that actually has a chip in it that you can actually calculate this area under the curve very accurately, and it actually is referred to as the effective value or the RMS value. Now, if we go back to the 1 volt waveform and we put the meter on it that has the RMS chip in it, it would come out a reading of 0.707 volts RMS. Well, you can see that the average value is not quite the true effective value of the waveform. So testers that don't have the special chip in them, what they'll do is they'll take this average value, and they know if they take the average value they see of the waveform, and it could be a 100 volt or 200 volt waveform, they take the average value, they multiply it times this average, and then they will take that number, and then they will multiply 0.637, for instance, here in a 1 volt waveform, times 1.11. And if you do that, you'll come up with 0.707. So they slightly tweak the number, so to speak, if you want to call it that, okay? Where a true RMS meter is actually going to go right to the value, okay? And actually calculate that area under the curve. Now, and it's kind of interesting, if I had you guys take a piece of test equipment and you measure the AC voltage at an outlet in a room, what would you expect the meter to read? And if you're going to say 120 volts, you'd be correct, because that's what it is here in the United States and in North America. But what is the peak of the waveform? Actually, normally see this peak is actually more like 170 volts, okay? And if you take 170 times 0.707, you'll come up with basically 120 volts. So, but again, you could do that with just using these numbers if you care to. But a true RMS meter is actually going to calculate this area of the curve for us, okay? And, these work great as long as the waveform is nice and clean looking. And, something's really changed in the last handful of decades. And you know what that is? That's the microprocessor has really become a huge part of our lives. I mean, it's everywhere, from electronic lighting to obviously your computers and TVs and all the other devices. And You know, the microprocessor basically needs DC, and we're going to plug the device probably into an AC outlet. So the device has to convert AC to DC. Now, in the process of doing this, these power supplies, many of them will actually start to distort this waveform, and this waveform is no longer nice and clean. We get into what we call harmonics in buildings, okay? And then on top of that, all these electronic devices that you find out there, you know, they're devices that can turn themselves on, you know, resistance-wise, on and off very quickly. And they can draw current at irregular times. And what happens is the load is not what we call linear, where we get a steady amount of current being pulled. We get nonlinear loads. Then these nonlinear loads also add to this whole harmonic problem. And you know, the more electronics you have in the building, the bigger this whole harmonic problem will be. And all of a sudden, this waveform is not quite, you know, looking quite like it should be, okay? And you know, average responding testers are going to have trouble measuring this, okay? And it's really gotten to a point where most people recommend you buy true RMS meters today because of this. And you know, average responding have their place. Just be aware of what they are. But you know, they can be upwards of 10, maybe 15, or 30, closer maybe sometimes to 40% if the harmonic problem is bad enough inside of the building. So be aware of, if it says true RMS on it, that's what it means, and you're probably going to pay a little bit more money on it for it. And if it doesn't say true RMS, you can assume it's probably average responding, okay? Now, and also these average responding with other devices too have problems. You know, they, like electronic dimmers, for instance. You know, dimmer, when I got the dimmer all the way cranked up, like the light's, you know, nice and bright, and we get a nice full portion of this waveform going to that light bulb, supplying light. But the dimmer, if you crank it down, those dimmer circuits basically are going to clip the waveform, and it's going to remove this portion of the waveform, and again give us half the power or half the light. And now this doesn't look anything like a sinusoidal waveform. So again, these average responding testers might have difficulty reading those type of voltages or, again, currents. So be aware of that. If be looking for true RMS or average responding, that's a big feature. This next tip is about measuring current. And if you need to buy a tester to measure current, either AC or DC, you have another choice to make. And the question you might ask yourself is, how much current do I need to measure? And that's going to make a big distinction as between which one you pick. And you have two basic choices here. You have what's referred to as digital multimeters, and then we have what's referred to as a clamp meter. Now, clamp meters basically clamp around a conductor, and they can actually measure the magnetic field coming off the wire and then safely turn that into amperage. Now, digital multimeters don't measure amperage this way. Digital multimeter actually measures amperage in what we call series, or in line with the circuit, and you actually have to make the meter part of the circuit in order to measure the current. So in this case here, we have a battery and a resistance and a little switch over here which is open, and I'm going to take the test leads from a tester and take the leads and set it across the open switch, turn the tester to the amperage setting, and now that in this case the DC amps would be actually flowing through the meter, and we can safely measure them, okay? Now, since the amperage is flowing through the meter, this is why we have a limitation on digital multimeters, because at a certain point it doesn't become safe. So you'll find most of them stop around 10 amps. You might find some that go out to 20 amps, but you're going to find out they don't go above 20 amps. And in obviously electrical AC circuits, we could be pulling more than 20 amps pretty readily. So not something we could use. We'd have to go out and buy, again, the clamp meter type thing. So be looking for that, because that's a big distinction between the two meters as far as where it's safe to use. Now, clamp meters, they get their name by basically clamping over the hot or the neutral conductor. And again, they measure this magnetic field coming off the wire and safely convert that into amperage for us. And you can buy these up to like 2,000 amp clamps. And for a lot of electricians, a 200 amp or 400 or 600 amp clamp might be all they need. Okay, and these will have a lot of other functions as far as regular digital multimeters and stuff like that too. So be looking for that. Now, when you clamp over wire, by the way, you can't clamp over the hot and neutral. So if I have the hot and the neutral conductor and I put them both inside the loop or the clamp there, you know, on the hot wire, the electrons are flowing into the circuit, and they're all flowing out of the circuit through the neutral wire. So the magnetic fields the two wires are creating are equal and they're opposite of each other. So if you clamp over both of them, that obviously is going to give us no reading. And usually that's a good thing, but in the clamp, no, it's not a good thing. So be aware of the fact you can't put them both in there. It's usually the hot is the one we can go out and find. So there's a big tip right there. How much current do I need to measure? And that'll make a big difference between 1 and the 2 meters. Well, those are all good tips to use when you're standing in the aisle trying to choose which one of these meters in front of you is right for you. And besides the basic current and voltage measurements we talked about, you know, a lot of these testers will do a lot of other things, but you got to ask yourself, where do you expect this tester to live? Is a really good one. And because some products, like this product here, which is called our Volcon unit by us, it does voltage and continuity, it's rugged, it's durable, I can throw this in the back of a truck, pile my conduit benders and all my tools on top of it, and a week later dig it all out of there, you know it's still working. Where digital multimeters probably aren't going to be like being treated like this. And of course, these generally do a lot of other things besides, you know, just the basic voltage and current measurements. They'll do resistance, they'll do temperature, frequencies, and capacitance, a lot of different things. And again, just buy a tester that does what you need it to do. And when you go to higher end testers versus the more modest type testers, look for the true RMS versus the average responding. That's one big difference there. And then the more expensive testers you buy generally are more accurate. So if you're concerned about the accuracy in a meter, you might check that out. Again, that's in the specifications with the meter as well. So, and on top of that, look for that UL designation and look for that category, because again, it's going to tell you a lot about where it's safe to use this piece of test equipment. And of course, you know, for current, we got to figure out, you know, we want a clamp meter or maybe a digital multimeter. So those are all really good tips to use as you're out there making a decision as to what tester you might want to buy. So good luck to you out there. My name's Ron. I'm with Ideal, and I'll see you next time.